Everybody, and welcome to the Intro to Neo4j for Developers training. Good morning, Lou. It's morning for us, but maybe it's afternoon for you. So we are, happy to have you here on this training in this, late November
Yeah.
day.
Yeah. Good morning, good evening, good afternoon, where you are. I mean, by all means, pop it in the chat. Where are you? We'll do some shout outs. Why not whilst we carry on? So we've got some from Paris, we've got Poznan, we've got Newcastle,
Cologne,
Cologne.
yeah,
Wow.
London.
Obviously you're in
London.
Munich,
I'm,
Alex,
I'm in
so
Munich. You're in London, exactly.
absolutely. So good morning everybody, good afternoon, good evening. I'm really excited to see who else has joined us. Right.
Yeah, it's
I guess we
great.
should get cracking.
We can get cracking. Yeah, I think maybe just as a
Absolutely.
quick introduction. So
Of
we will
course.
give you an intro. Obviously, Lou is our developer relations advocate here at Neo4j, and she will give you today a quick and easy overview of how to get started with Neo4j. What is a graph basics 101 sort of. Good graph scenario spotting. So I think that's an important key learning of this session today, and then obviously hands-on with the sandbox. So I think Lou also posted the links already, and there's in the little blue box sticky note up there as well, or down here in the screen. Go to neo4j.com/sandbox and start your free sandbox. You just need to register with your email address, and then you're good to go.
Absolutely, absolutely. So I'm going to quickly do a few more locations, and then we're diving straight in. So yes, hello. We've got Bangalore. So hello, Bangalore. We've got a few more from India as well. Good afternoon. Good afternoon. We have got Australia as well from Sydney. So
Yes.
good evening, Sydney. We've got Ellsberg as well. Good afternoon. Oh wow, look, it's Japan as well. Fukuoka. I apologise for that. So yes, good evening, Japan as well. Wow,
That's
and
great. That's great.
Nanded as well, and Vienna. Wow, my goodness, we have got a very, very global attendance today. So this is going to be fun. So right, let's do this. We're going to have good fun. This is a code along, so I am going to get you all from understanding what a graph is. So we are going to do the bare bones. What is a graph? As Alex said, we're going to look at the anatomy of a graph database. We are going to be talking about how you spot good situations where a graph database makes sense. Why do we need graphs? I am going to then give you a crash course in Neo4j Cypher. And what we are going to do, we're going to take that knowledge and we are then going to use the Neo4j Sandbox. So we're going to be using the Neo4j Browser. So yes, somebody mentioned, are we using it? Yes, we will be. So we're going to be using the Neo4j Sandbox, and we are going to be writing some Cypher. We're going to be doing some queries against a graph database. So we're going to be using the movie database. So we are going to have a huge amount of fun. And at the end of this, you will have had a go at doing a Kevin Bacon number. You will have had a go at building a recommendations engine. So we're going to be covering a lot of ground. We're going to be moving quite fast, but don't worry. You'll be able to then, at your leisure, go through the sandbox and have a go at your own pace. So we're going to be covering a lot of material. It's going to be great fun. If you have questions, pop them in the chat and we will I'll pick them up as we go along. This is also being recorded, so if you go, I need to go over it again, don't worry. This will be available in our YouTube channel. So that's youtube.com/neo4j. So that will be available. Okay, right, let's do this. So what we're going to do in this session, we are going to be covering what's a graph and why we need them, spotting good graph scenarios, property graph database anatomy, and an introduction to Cypher. We are then going to do the hands-on element. So we are going to be working with the Moviegraph dataset on the Neo4j Sandbox. So Sandbox is completely free, so you'll be able to join in. Just as a quick shout out, if you want to get ahead of the curve, you'll spot at the bottom of the video, we have a link to the Sandbox. So you can go on there now and register so that you are good to go and start a Sandbox. You've got the address there. And then I'm going to talk a little bit about how you can continue your graph journey. So where can you go to get more material and so forth. Okay, so what is a graph? A graph is a set of discrete objects, each of which have some relationship with each other. So commonly when people think of graphs, maybe they may think of something you get in Excel, those pretty diagrams. So those are charts. So strictly graphs, graph theory, it's a branch of mathematics, and it's all about discrete objects and how they relate to each other. And this comes originally from the 7 bridges of Königsberg. So Königsberg, which was in Prussia, now modern day Russia. So Kaliningrad, so you may remember Kaliningrad from the recent World Cup. So originally it was Königsberg, and in this town of Königsberg, they had these, 2 land masses. So the mainland, so either side of this river, and a couple of islands. So you see there on this diagram, you had these 4 land masses, and they had 7 bridges connecting these land masses together. And somebody thought, you know what, that would pose a really interesting maths question. And the question was it possible to visit all of these land masses, so the 2 parts of the mainland split by the river and the 2 islands, crossing these 7 bridges, but you had to cross these bridges once and only once, and you had to cross every single one. And this was posted in a newspaper, and famous mathematician Leonard Euler saw this and thought, oh, that's interesting. And what he did was he said, well, actually, let's take this, let's simplify this problem, because actually what we're interested in are these 4 discrete entities, these 4 land masses, and the different ways that they're connected, so these bridges. And effectively what he did was he said, well, let's take those 4 land masses, and we're going to say these are discrete objects, and let's take these 7 bridges, and we're going to say these are the relationships that are connecting these 4 bridges. And thus graph theory was born. And absolutely anything can be a graph. So the internet can be a graph. And there's lots of different ways if we think about how can the internet be a graph. Because remember, we're thinking about discrete entities and how those discrete entities are connected. How are they related to each other? So for example, if we think about how we're connected on the internet, so we can think about different entities. So for example, I could be a discrete entity. Alex is a discrete entity. We think about how the different ways we communicate, those could be the relationships. Maybe I send a message to Alex on Slack. That would be a type of connection. Maybe I send an email to Alex. Maybe Alex sends me a text message. You've got all these different intricacies of how these things are connected. The internet could be referring to the actual physical components of the internet, and we think about how we connect to the internet. We've got our computers, maybe we're using our mobile devices, maybe we're using tablets. We've got Internet of Things devices, so we've got our smart hubs, we've got our smart light bulbs, and then we think about all of the underlying infrastructure. So the fact that we're connected to a Wi-Fi router, we've got cabling that connects to fiber, we've got routers, we've got servers, we've got the bare tin and metal and the wires that connect everything. So that is a graph. There are many different ways that can be a graph. What about chemistry? A water molecule can be a graph. So if we think about what water is, so water is oxygen and 2 hydrogen atoms. But it's not just a case of, well, we have these 3 atoms. It's how they are connected that gives you a water molecule. So here we look at it and we say, well, actually, we've got an oxygen atom, and it has a relationship with 2 hydrogen atoms. So two relationships connecting to 2 hydrogen atoms. So it's a water molecule. So absolutely anything can be a graph. Anything where you have connections, and we're interested in how discrete entities are connected to each other, is a graph. So, okay, we've touched on what is a graph. We've looked at a couple of examples of graphs. So why do we need graphs? And if we sort of take a step back and we think about a problem that we might be solving, where we may be using technology and IT to solve something, generally, problems are best understood with the representation of reality. And if we think about how we're representing this reality when we're solving a problem, inevitably, we are going to draw a diagram, we're going to maybe draw some arrows, we're going to draw some circles, and we're going to provide a representation of this reality. And inevitably, it's going to be about things connected to other things. So if we think about this picture, we've got a person here who's drinking a coffee, and if we wanted to represent that reality, we'd have a person, we have the coffee, And we have that connection between them. So they're drinking a coffee, and explicitly here, they're drinking coffee in store. But if we dig a little bit further, so let's say what we're trying to understand here are the different ways a customer interacts with us in a coffee store. So we're going to be looking at what beverages are they purchasing in store. We're going to be looking to understand, well, what was that action? So did they, get a takeaway? So did they come in, get their coffee and take away? Did they pre-order it? So we have many coffee apps now where you can pre-order your beverage and it's ready for you to collect. Did they drink in store? So we think about the various things we're looking at here. And if we think about the more traditional ways of how we'd be capturing that data and storing it, we'd be looking at a relational database. We'd probably be doing some kind of normalization to that data. And we're going to end up, with mapping things. And this isn't very represented. This isn't a reality that we started off with when we started trying to understand what's going on. And if we dig a little bit further, what happens is if we've got a very huge amount of data here, so we've got a chain of coffee shops all over the place, they're probably going to have discrete databases that store in this data. And again, we don't stop at these data silos. We don't go, right, well, that's customer here and that's product here. We were trying to connect these different things together. And what's really great about working with a graph when we're dealing with connected problems is that it allows us to have a better approximation of reality. So we can have these nodes, these vertices that are able to capture this discrete entities, a discrete entity of customer, the discrete entity of the product, this beverage, coffee, and we can show how they're connected. And that allows us, when we're working with graphs, to store that as that representation of reality. So this will make more sense when we start to work with some examples. And I'm going to give some high-level views of things about why I get excited about graphs. And the first example I'm going to work with is trainers. And this is following the flow. So what happened about this story about when a pair of these trainers, this product here, it's a product type of trainers. It has a price of $89.99, 90 of your chosen currency. And what we can see here is we've got three nodes, three-person nodes, three-person vertices. And we've got one here, a person node, we've got a name of Jane. And Jane buys these trainers and she buys them at a certain date. Alison and Ian also buy these trainers. And what we can see is that these events happen to this. So Jane first bought the trainers, then Alison, then Ian. So we can do that by looking at this property on the relationship between the person and the product. And I think there's a bit more going on here. And let's dig a bit into this. And I think there's a bit of influence going on here. So in this theoretical example, let's say I'm going to pull in various social media data sources. So Jane bought these trainers, and it turns out she was very happy with those trainers. So she tweets about them that she loves her trainers. And it turns out that Alison follows Jane on Twitter. She reads that message, and that has influenced her to buy these trainers. Alison's also very happy about these trainers, so she posts an update on Facebook that my trainers are brilliant. Ian is friends with Alison on Facebook. Ian reads the update, buys the trainers. He's also very happy with these trainers, so he posts a picture up on Instagram of his trainers and so forth. And this is a very simple example, but you start to see the power of understanding the relationships between these entities, because we've got people here, we've got a product here, and what we can start to see is there influence going on, and we understand potential influence based on behaviors that people have and how they interact with each other. Another one, Panama Papers, a simple model, powerful outcome. So many of you may recall the Panama Papers, the Paradise Papers, the Swiss leaks, and so forth. And this was done with an underlying graph database. And what I'm going to do is I'm going to just quickly talk through the model. And don't worry too much. We've got a lot of relationships here. We've got a lot of entities here. I'm going to talk through them. But the basic gist of what's going on is this was the data model. And we have got separate nodes here, but these are some nodes can have more than one label. Don't worry, we're going to touch on the anatomy of a graph database shortly. But what I'm trying to highlight here is we've got a very simple model going on here. So we've got an officer of a company. So, an officer might be a director, they're a significant shareholder, so forth. We've got an entity. So an entity can be our company, and a company can own another company and so forth. And we've got an intermediary. So these are intermediary companies that may have some kind of management or directorship or ownership and that kind of thing. And what you'll see is that they all are connected to an address. So we're effectively looking at either an entity that maybe owns a company or is a shareholder of a company or is a director of a company or an intermediary company, and they've got a registered address. And why this was so powerful when we think about the Panama Papers and what happened is because as soon as we know that something is connected, so as soon as we know that an entity owns another company, or entity is a director of another entity, entity is a shareholder of an entity and so forth, we put that connection in. So we understand that they're connected. So we put that connection in. And we can also have a look at their address. And why this was so powerful, I thought I had my other slide on here. So the reason why this is so powerful is when we think about who was connected to the Panamanian law firm, where people were using it to be tax efficient, tax avoidance, that kind of thing, is all we need to do is like a Christmas light. We start at the start point, which is a prominent politician or a business person. And then we just keep going, well, do you have a connection at some point to Panama? Yes, you do. And this is the beauty of it. And we get to see an example of this when we work with the Kevin Bacon numbers later, is that it's very easy for us to see if there is a connection. And it doesn't matter how many hops you have to go through. It doesn't matter how many entities you have to go through. Because as soon as we know that two entities are connected, we put that connection in, and then all we have to do, if you think about it like a row of Christmas lights, we just need to follow that line. And it doesn't matter how long it is, we just follow it until we hear connection. Next one. So if you think about Facebook, if you think about LinkedIn, and when it pops up and goes, hey, you might know this person. And the reason, that happens is we can start to infer connections based on the existing connections that we have. So if we think about friends of friends, so if I'm friends with Anne, Dan, Zane and Jane, and Bob is friends with Anne, Dan, Zane and Jane, we can go, well, we've got 4 friends in common, so there's probably a really high likelihood that I know Bob. Or if you think about it from a different perspective, maybe Bob and I should be introduced because we have so many common friends or common connections. So you see that as friends of friends, it's a great way to spot influences in a network as well. And one example that we're going to be looking at later is going to be co-actors of co-actors. So this is what we're going to look at in the movie data set. So these are really great examples of where we see graphs. Oh my goodness, I've just spotted we've got somebody from Las Vegas here. Wow. Yeah, that is insomnia. Okay, so let's quickly have a look at some good graph scenarios before we dive in and learn some Cypher. So I've got 4 scenarios here to help you quickly spot what are good graph scenarios, because not everything is a good use of a graph database, but there are some really compelling ones, and just want to give you some hints and tips to be able to spot them. So the first one is, does our problem or does our graph challenge involve understanding relationships between entities? So this is a really obvious one, and we had a quick look at one with trainers. So we've got the idea here that, Lisa buys a t-shirt, which is a part of a specific t-shirt, which is part of a t-shirt category. And we've got Jane, who buys another different type of t-shirt that is part of a t-shirt category. So this is really useful if we want to try and create recommendations. So if Lisa also went on to buy a category of type sunglasses and a category of type shorts and a category of type flip-flops, and Jane also buys flip-flops and sunglasses, maybe we can infer that they're both going on holiday, so we can start to create some holiday product recommendations. Fraud detection. If things are starting to behave in a certain way, if people are behaving in a certain way, if they're sharing the same addresses, phone numbers and other details, we can start to predict if there's something interesting going on, find fraud rings, and do something about that. Finding duplicates. So we can use graphs and graph structures to help rule out duplicate information. And data lineage, just understanding how our data is being used, how it's being transformed, and so forth. Another scenario, does the problem involve a lot of self-referencing to the same type of entity? So, for example, organizational charts. So who manages who? So everybody in this example here is an employee, but employees manage other employees. And this is something that can be really hard to try and query in a tabular database or in a relational database. This can be hard. A lot of these self-referencing joins going on, but in a graph database, these tree structures are very graphy and they're very easy to query. So organizational hierarchies, access management. So if you are managing permissions to various documents and files and folders and so forth, these are really nice ways that you can go around and use these structures. Access management. So, for that, social influencers. So we have touched an example of this where we think about who's influencing who, and we start to look at those connections and the depths of those connections. So can we identify who's more influential network than others? And friends of friends. So we looked at that example. Can we make recommendations about who could be friends with who, or new connections, icebreakers, that kind of thing. Let's look at another scenario. Does the problem explore relationships with varying or unknown depths? So the example here, let's say we have 3 organizations here. We've got Pencils Are Us, We Love Stationery, and We Sell Wood. So We Sell Stationery buys pencils from Pencils Are Us. So Pencils Are Us are a big producer of pencils, and they sell pencils to stationery companies such as We Love Stationery. Pencils Are Us are manufacturing the pencils, so they have to buy some raw products. So they buy wood, and they buy wood from We Sell Wood. So We Sell Wood are growers and processors of wood, which they then sell on to companies that use wood for their products. And We Sell Wood buys pens as part of their office function from We Sell Stationery. And the point here is we can start to understand the different connections here and what are the impacts. So for example, here, if We Sell Wood went out of business, then that's going to have a knock-on problem for Pencils Are Us. So where are they going to source their raw product from? We Sell Stationery may have a limit, may have some sort of a limited impact from We Sell Wood because they're no longer selling pencils, but there may be a bigger problem in the fact that they can't source pencils anymore from Pencils Are Us. So this kind of connections, because as soon as we know things are connected, we can explore those connections, can be really interesting in things such as supply chain visibility. So understanding, where products are being sourced from, what are the potential disruptions if something or some company goes out of business? What's the potential impacts if there's a new business that comes in? What are the impacts if there are seasonal issues? So let's say, for whatever reason, if you are dependent on a certain crop, so for example, cabbages, if there's been a very wet summer, there's going to be a reduction of cabbages. So what's the knock-on impact in the supply chain with regards to supermarkets, restaurants, that kind of thing? Bill of materials, same idea. If we're trying to understand the components of where different things are being bought, and different components put together, so you think about a car, different wheels, you're going to have certain configuration dependencies, and the graphs are a really great way of being able to manage that. And network management. So just being able to understand that if a router goes down in a certain part of your network, what impacts is that going to have on your applications, on your servers, on your users? And last but not least, does our problem involve discovering lots of different routes or paths? So this is probably the really classic graph challenge if you think about it. So last year, as an example, so I'm based in London and I went to a conference in Edinburgh. And on my way up to Edinburgh, I decided to go up the east coast of the UK. So I went from London, and the stops on the way were York and Newcastle. And then on the way back, I went down the west coast of the UK. So I went past Lancaster, I went past Crewe, I went past Rugby. And where graphs can be really powerful is determining the most efficient route across a network. And the efficient route across the network could be by cost. So is it cheaper to go down one route? So maybe the train tickets are cheaper than one route or the other. Maybe it's by mileage. Maybe I want to do a weighted shortest path. I want to do it by minimizing the number of miles. Maybe the cost is going to be speed. So maybe it's quicker. So not relevant here, but if I'm driving, maybe it's longer to go down a motorway with regards to miles, but because I can drive at 70 miles an hour down a motorway, whereas on residential roads I can only drive down at 30 miles an hour, maybe I want to do the route planning there. So great examples of this are logistics and routing. So routing could be on roads, routing could be on networks. So, what's the most efficient way of sending a packet of data down your network? Infrastructure management. So again, if you're planning your infrastructure, do you need to put in more dependency routes? Do you need to put in more paths? So again, with dependency tracing. So if you've only got one realistic route available or something happens, how do you manage that? So we've talked enough about the identifying scenarios, why graphs are powerful, why they're useful, and graph-shaped problems. Let's have a quick look at the anatomy. So we've talked a lot about this theory. So let's start looking at the anatomy and let's start looking at some Cypher. So I've mentioned it a lot. I mentioned this word node a lot. I've mentioned vertex a couple of times. So this is one of the main components of a graph. So a node, which is what we refer to them in Neo4j, or a vertex in graph theory, that is our main entity. That's our discrete entity from which graphs are constructed. And then we connect these nodes, these vertices, these entities with a relationship or an edge. So they're also known as edges within graph theory. And this is the link between two nodes. And with property graphs, that's what Neo4j is. It has a direction and it has a type. So we can see here we have a relationship between these two entities. It has a type of owns and it has a direction, which we have shown with the arrow. And something to mention here is that you can have nodes without relationships. So you can have orphan nodes. So we could have a Jane node and Jane could be connected to nothing. But you can't have a relationship without nodes. So we couldn't have that owns relationship floating on its own. We have to have two nodes to connect them with. Okay. So I mentioned that Neo4j is a label property graph database. And what that means is we have labels. And labels are a way to define a category for a node. So these are optional, but in practice, you will pretty much use them all the time. And they are a super useful way to be able to say what our node is. So for example, we've got a person node and we have a car node. So we can very quickly look at this picture here and we know that we have a person owning a car. That's our concept. That's our representation of reality, as we mentioned before. And you can have more than one label on a node. So this is really useful if we're trying to look at different viewpoints of our data. So we may look at a viewpoint of a person owning a car, and that may be relevant if we're thinking about, information about that car. But what if we're looking at this from a assets viewpoint, from an insurance viewpoint, and you're going to be insuring your television, you're going to be insuring your car, your computer and other equipment, your bike, maybe some jewelry. So these are all assets. And whilst there may be, whilst we may be interested to say, a type of jewelry, a type of computer, from an insurance perspective, maybe we want to know that they're assets as well, their values. And another thing we can do is add properties. And properties we can add on both nodes and relationships, and they're a really great way for us to enrich our nodes and relationships, to put more information and perspective about them. So for example, with a person node, we probably want to have a property of name and Jane because we're going to be dealing with person nodes. Or if we look at the car, maybe we want to know about the make and model. And what we can do as well, we can add properties on relationships. So here it makes sense for us to know, when did Jane start owning that car? So we've got a property key of since and the value of 2018. So you'll see with properties, we always use this key value pair setup. And the thing to point out with this setup is we don't need to worry about nulls. So maybe for person node, we have a property of a Twitter handle. So maybe Jane's on Twitter, so we could have Twitter handle : Jane123. Maybe we've got another person node of Dan, Maybe Dan isn't on Twitter. We don't have to have this situation of Twitter handle : null. We just don't add that property at all. So it's super flexible, and we don't have these sort of sparse matrices filled with nulls. We don't need that in a graph database. That is pretty much the anatomy of a graph database. Pretty good so far. So let's start looking at how we'd go about querying it. So we use Cypher, Neo4j Cypher, and that is a pattern matching query language made for graphs. And some of you may have come across OpenCypher, so that's one of the projects that we're working on, and GQL, which is again where we're looking to do sort of standard graph languages, standard query language for graphs. Quick question: will the slide deck be available? Yes, we can make it available. Okay, so Cypher, and we'll see why it's a pattern matching query language when we have a go ourselves shortly. But it's a declarative language, so we need to ask what we want, and Cypher will figure out how it's going to respond. So what do I mean by that? So if I want to know if it's raining outside and I ask my husband, I don't need to tell him to give him explicit instructions about going outside, opening the back door, looking up at the sky, is there water coming out of the sky? Yes, therefore it's raining. I could say to my husband, is it raining? And then he can choose how he's going to answer that question. Maybe he's going to choose by going outside and having a look. Maybe he's going to look out of the window. Maybe he's going to go and have a look at BBC weather. So he's got a number of ways, and in this declarative form, in this example, Cypher is going to work out how to answer your query for you. It's expressive and pattern matching. And what do I mean by pattern matching? We use ASCII art. It's brilliant, great fun. It's easy to see the patterns. So let's do this. So if we want to retrieve nodes, if we want to retrieve our entities, we use this concept of match. So match to retrieve nodes, and then we return something. So let's talk a little bit about what's going on here. So we represent nodes. We're using our ASCII art, and we represent nodes with round brackets. So you can see here, plain round brackets represent our nodes. And here we're putting in a variable, a container, to catch the result of our match. So here I'm calling it n. We could have called it anything, and then we return something. So here we're returning our variable of n. And what this will do, it will match every single node we've got in the database and return n. But we might go, oh, hang on a minute. I don't want to return every single node in a database. What I want to do is I want to return every single person node in my database. So what we do is we're going to use our label. So here, anything following a colon in a node or in a relationship is going to specify either the node label or the relationship type. So here I'm saying match n. So here's my container, my variable that's going to store the result, colon person. So match all nodes that have got the person label, return n. And that's going to return all of my person labeled nodes. If I go, well, actually, no, I don't want to return every single person node in my database. I want to return all my person labeled nodes that have a property of name with Tom Hanks value. Okay, so what we can do here is we say, well, again, round brackets, because we're matching nodes, match n, our variable, with the label of person, and then we represent property variables with the curly braces, and this is same for both relationships and nodes. So open the curly brace, we've got our key name here of name, colon, Tom Hanks, at which Tom Hanks is a string, return n, and that's going to return all person nodes within our database that have the name of Tom Hanks. So something to mention here is when we do the property name like this with the curly braces and Tom Hanks, this is an inline property, and this only works with an exact match. So what I could do as well, and notice I've changed my variable name, so it was n previously, I've changed it to p now. So what I could do is if I can say, well, actually, I know in this example I want to do an exact match, but I can use the where clause, and the where clause allows me to do non-exact matches. So here I'm doing an exact match, so a bit like in SQL, I use where. So here I'm saying where p.name. So if I want to access the property of a node or relationship, I use the variable that I'm referring to, and I do dot name. So we know we've got a property on there, property with the key of name. So I do dot name equals Tom Hanks returns P. So this is the equivalent query to the one above. If I want to return some nodes that are movies, and specifically I want to return movies that were released between 1991 and 1999, I can use the where clause now because I have the option to do a range match. So there you go, I'm matching M movie because I'm interested in those with the movie label. Let me just move this mouse out of the way. Where m.release, so we're accessing the released property here, is greater than 1990, and m.released is less than 2000. So very similar, should be recognizable syntax there. And return m, and that's going to return all of my movie nodes that have a released year property between 1991 and 1999. Okay, so we've been talking about nodes. It's now time to extend that pattern that we're looking at. So everything to the right of the match is the pattern. So we were looking before at patterns where there were just nodes. We're now going to start returning nodes and relationships. So if I wanted to find out all of the movie nodes where Tom Hanks has acted in them, then what I would do, so we know how to find the Tom Hanks nodes. We've done this before, so we do our round brackets because those are our nodes. We have our person label. We have the property for Tom Hanks. And then what we do is we represent relationships as an arrow. So if I wanted to know about all of the Tom Hanks movies, irrespective of whether he acted or directed them, I could just do an arrow. So you can see here, I could just do hyphen, hyphen, arrow to movie. If I wasn't sure about the direction, I could just do hyphen, hyphen, movie. So that's a relationship. If we want to specify a relationship type, then we use the square brackets. So relationship information is represented with the square brackets. So here we're saying match Tom Hanks acted in to a movie. So movie's a node, remember? So there you go. We're back to the round brackets to represent movie. We've got our container, our variable for movie. So we've got M, and then we're specifying the type here. So colon movie. And that's going to return movie. But we said we wanted the title of the movies. So what we do is return m.title, and that's going to return all of the values for the property of title. If I want to take this a bit further, and actually what I want to know about are all the movies that Tom Hanks has directed in and ordered by the latest movie. Again, very similar principle to what I've done before. We've changed it to directed because we want to know about the movies that Tom Hanks has directed in, so that relationship. And then we're going to return the movie title. We're going to remove return the released year, and we're going to order it by the released year descending. So very similar to SQL there, similar kind of setup and syntax. If I wanted to know about all of the co-actors that Tom Hanks has worked with, then what we can do here is match. We're going to do this. So quick question. We've got some questions coming in. I'm going to answer these whilst we're doing the activity. So I'm not ignoring your questions. I'm just going to wait until we start doing the exercises, and I shall start covering them then. So hold tight. So if we wanted to find all of the co-actors Tom Hanks has worked with, then what we would do is we match Tom Hanks, so we know how to do that. Notice here, I don't care about whether Tom Hanks had acted in that film or directed that film. I just want his relationship with movies. So here I've got the hyphen hyphen arrow to our movie node, and then we're going back out. So I want to know about his co-actors, who, the actors that he's worked with. So there we go. I then go back to movie. So I want to know about actors, not co-directors or anything like that. And then I go to person node. So I've now got a variable name of co-actors. And here I return co-actors.name. Pretty good so far. You're going to have a go at this hands-on, so it'll make more sense when you do the doing. Okay, so we can create nodes as well. And what we do here is we swap match for create, and then we use exactly the same syntax before. So if we want to create a person node with the name Tom Hanks, we do create. If I want to if I want to create a relationship between two existing nodes, so I've got an existing person node of Tom Hanks, I've got an existing movie node with the title of Apollo 13, then I match those two nodes. So I bring a match and I've got a relationship between those. And then I do the create, and now I'm creating that relationship of acted in between those two existing nodes. If I was going, you know what, I don't have a person node of Tom Hanks. I don't have a movie node with the title of Apollo 13. And I certainly don't have the relationship between them, because remember, the relationship cannot exist without the nodes. I could create the entire pattern. So remember, anything to the right of create, anything to the right of match is a pattern. I could create the entire pattern in one single motion, and I could do the create person with the property of name Tom Hanks, acted in, oh, I've missed the curly brace there. I'll fix that in the slides later. Acted in movie, so node with the label of movie, title Apollo 13. So I could do that in one go. Right, okay, I've been talking for way too long, and it is now time for all of us to have a go with this. We are going to be working with the movie graph. We're going to be going through these problems together. So if you ever get any questions and you get stuck, let me know. I'm keeping an eye and we shall go through those. So we are going to use the Sandbox. So you have got links. So either sandbox.neo4j.com or neo4j.com/sandbox. They all work the same. They will get you to the same location. So what you need to do is, I would prefer if you do this Sandbox, because it will get you there straight away. So you're going to go to the link. I'm going to quickly fire that in the chat. Do that. You're going to sign in, and then we're going to select a blank Sandbox and launch a project. So all good. So we've got the link, I think, being fired out. So let's do. So just use that link. And we are going to go. So we've got a quick question here about updating node property and relationship properties. So let's have a go with that whilst we do the exercises. So I've not specifically done an example here, but it's super easy. So we will do an example and we'll update maybe Tom Hanks's name. Let's do that whilst we go for the example. So if you go to sandbox.neo4j.com, if you've not already done it, you'll get a little pop-up that says sign in. So if you have some options, you can sign in with social media, so you can sign in with your Google account, I believe with your Facebook account. If you want to be more traditional, you can click the other tab to register a new account, and you can supply a password, so email address and password. So you can use that approach as well. And once you've logged in, you will be presented with this screen, and then we will select a Sandbox. So I'm going to give you a couple of moments to make sure you've gone onto the Sandbox and you are logged in and you've got the same screen as me. So whilst we wait for that, let's have a quick look at some questions. So we've got a question here. Will you take us from beginner through to advanced? So this is very much going to be beginner at the moment. So this is a very short session. There's only so much we can cover in 90 minutes, but we do have a huge amount of material, and I'll point you to it. We've got free training, we've got webinars, we've got all sorts to progress you through that. We've got a free certification program as well. So we've got a huge amount of material that you can use to help you through this process. And we will look at those links as well. And what I would suggest as well is we have regular Twitch streams as well. And for example, I've got my colleague Florent, who's going through Go, so building an application with Go. My colleague Will is doing a lot of stuff on GrandStack and React and building applications with Neo4j. I do a lot of stuff working with Cypher and data wrangling and that kind of thing. So we've got a huge amount of content. So I'll point you to some of the links at the end if you want to take your graph story further. Okay, so hopefully you are all looking at the same screen as me now. So what we're going to do is we're going to click on the new project button. And you'll see we have this option here, blank Sandbox. So that's what we're going to use, but let me just quickly talk you through the other Sandbox options. So Sandbox is completely free, and you can have it running from 3 to 10 days. And you have options from bringing your own data, so you've got blank Sandbox or the spreadsheet grapher, to if you're like, well, I want to have a play with Neo4j, but I'm not entirely sure. I haven't got a data set. I haven't got a project in mind. We have a load of pre-built data sets. So we've got movies. This is a more in-depth recommendation example. So that's if you want to do the more experienced stuff. Network and IT management, so you can have a play with that and work with dependencies. We've got a subset of the Panama Papers data set, which was released by the ICIJ, so you can explore with that. Crime investigation, graph data science, fraud detection. You get the idea here. So we've got a huge amount of different examples with pre-populated data sets and a guide that will walk you through those examples. So that's something you can have a play with in your own time, and you can launch these at different points and relaunch them. So you have a lot of good fun with that. But what we're going to be working with today is the blank sandbox. So if you click on the blank sandbox and click launch project, that will go away and start getting that set up. So that will take a few moments. So let's have a look at some questions whilst we wait. So what have we got? So how is graph database different from an ER model diagram of conventional databases? So that's a really interesting question, because if we think about an entity relationship model, that's all about describing how your, how effectively your tables are related. You may include extra information there about keys and so forth and that. So what I would say regarding that is that's a modeling convention that is being used to describe how you're going to set up your relational database traditionally. And the argument that I would say is you could theoretically adapt an ER model to describe your graph data model. But what I would say there is that your graph data model is going to be different from your relational data model. So if you normalize it with your mapping table. So I think that's sort of a mix of terms. So what I would say is ER modeling is a tool. It's a way to describe and annotate your data model, which is traditionally used for relational data models. And what I would say is it theoretically could be used to annotate your graph data model. But the takeaway message here is how you go about modeling for graph and how you go about modeling for a relational database is different, especially if you're looking at the physical data model itself. That's going to be different. So hopefully that helps answer that. Okay, I'm going to pick these up as we go along. So hopefully everybody's got their sandbox now launched. So what we're going to do, I'm going to quickly talk you through what's going on here before we continue. So you'll notice we have this little down arrow here. So if I click the down arrow, we have a number of options here. So I mentioned that the sandbox will last for about 3 days if you do nothing. And you see here, it tells you when it's going to expire. If you are working on your sandbox, you go, I need a little bit more time. What you can do is you can press this button here and it's going to add another 7 days to your sandbox. So the maximum life you can have in the sandbox is 10 days. So don't panic, you can spin up another sandbox afterwards. So you're not limited to the number of sandboxes that you can spin up, but you are limited to how long they last. So this is very much a play area. Please don't do anything in there or bring up any data in there that you don't want to, don't want to lose. So don't do any processing, or at least take a copy of your data before you, before you end your play with the sandbox. You can invite collaborators to your sandbox, and if you're finished with this sandbox, you can terminate it. What you will find as well here is if I click on connection via drivers, so for those of you who have a favored language to work with, what you'll find here is instructions to pull the relevant Neo4j driver for that language. And you will also get a code snippet which you can copy, and it'll handle, have the what address you need to connect to get to your sandbox, the password, which can be very entertaining because these are auto-generated, the name of your Neo4j database, and a sample query, and how it's going to return the data from that. So that gives you a nice little snippet to get you connected and pull something from the database. So that's something you can play with, and you can pick which language you want. So there we go. Okay, right. So what we're going to do now is we are going to jump straight into the sandbox. So if I click on Open with Browser, this is going to launch the Neo4j browser. So we shall do that. And whilst that is firing up, let's have a look at another question. How is the performance of high cardinality join queries in Neo4j? So that is very much an it depends question. So assuming here you're talking about a huge number of relationships off of a node. So that is very much, it depends. So if you've got high dense nodes, so if we call them dense nodes, if you've got a node with many relationships coming off of it. So if you've got dense node to dense node to dense node, and you're doing queries that traverse through those nodes, then you're going to need to think about refactoring your data model to handle that. If you've got one dense node that you refer to that's then connected by lots of low density nodes, then that's not potentially a problem. So that's a very much it depends question. It's going to depend on your data model. It's going to depend on the questions that you're asking. And what I would recommend you do is have a look at our modeling training course, and it talks about that and ways you can refactor your data model, and how do you spot those things. Okay, so hopefully we have all got browser up and running, and what you'll see here is you will get this welcome screen. So I'm not going to go through it, but when you go back to Sandbox in your own time, this guide will show you the different components of the Sandbox and what they do. So I'm just going to close that for now. And what you will see, I'm just going to close this first one here, is what you'll see, you'll have this menu here. Now, this will always appear irrespective of how you've launched Neo4j Browser. So I've launched it off a Sandbox. If you download Neo4j Desktop and launch browser, you will have this option. If you use Neo4j if you use browser on Neo4j Aura, which is our cloud offering, and start browser, you will have this box. Irrespective of how you launch Neo4j, this will always appear. And the reason why I love this example that we're all about to do together is it is always available and accessible. It doesn't matter how you've launched Neo4j, you will always have this menu that pops up. If you accidentally close it, go, oops, I've closed it, that's not a problem. I mean, if you can't remember the place start, all we need to do is close the browser window, open browser again, and like a faithful friend, as soon as browser launches, it will be available and waiting for us. So if you accidentally close it, not to worry, you just close that frame, just open browser up again. Look, there you go. It is back. It is available for us. So the example I'm going to be looking at is this one here, which says jump into code. So if you click on write code, you'll have this pane that pops up, and we've got this one here that says Moviegraph. So Moviegraph is what we're going to be looking at. So let's click on create a graph. And this is going to pop up the play Moviegraph. So let's talk a little bit about what's going on here. So the first thing I recommend that you do is press this pin. So that's going to pin that frame in place, and it's going to stay at the top of our screen. And this play Moviegraph is what we call a guide. It's a browser guide. And I'm going to assume a question might pop up. You can create your own one of these. But these are guides, and what these guides do, and you'll find these in every single other sandbox that you look at if you explore some of the other use cases, is it will give you a set of instructions about what this example is all about, what you're going to do, and so forth. So here we've got the movie guide, and it tells us we're going to be inserting some data into the graph, we're going to be retrieving movies and actors, we're going to be doing various queries, and we're going to be doing a Kevin Bacon number as well. And what you can do is you can navigate back and forth through the guide using these arrows. And you'll notice that sometimes we have these grey boxes. And in these grey boxes, what that means is you can click on it, and it's going to send the code up into this part, which is the query part of the browser. So you don't even have to type much, which is in these examples. This is great. So you can look through the code and experiment a little bit. So experiment for a bit, so you can see that. So that's going on there. So let's start diving in. This is a crash course. We're hands-on, so let's do this. So let's expand this. So what you can do is you may be sitting here going, oh, this box is really tiny, I want to see more. If you press the escape key when you're in there, it will make the query window big. It will maximize it to the size of every window. If you go, right, I'm done with this, press the escape key again, it'll make it small. So let's just expand this and have a quick look at what's going on here. So you notice we have lots of creates. So if you remember when we're going through Cypher, that means we are going to be creating some data. And let's have a quick peek at what's going on here. So we have got a create, we've got a round bracket, so that means we're going to be creating a node. We've got a colon and movie, so we're creating a node with a movie label. We've got a variable here called the matrix. And if we have a look at what's going on, we're creating some properties for this node. So we've got a property with the key of title and the value of the matrix, a string of the matrix. You can use single quotes, you can use double quotes, that's fine, just be consistent. So if you start with a single quote, end your string with a single quote. If you start your string with a double quote, end it with a double quote. So we've got title of the matrix, we have a released year, so that's an integer, we've got a tagline, welcome to the real world. Okay, so we're creating a node label movie, we've got some values here, and we've given it a variable name of the matrix. So we create some more nodes. So here we're creating a person node with name and a year of birth. And if we go down a little bit further, we can see we are then also putting in a relationship between those two nodes. So here we're now taking the variable, which we know has, our Keanu Reeves node. We've got a variable name for the matrix here, which we know is our movie node. And we're then creating a relationship between them. So the relationship here is the acted in. So Keanu acted in the matrix. And we're adding some properties as well here to the relationship. And here we are adding the role. So what role did that person play in the matrix? And here we've got Neo. Some of you may be going, well, hang on a minute. Why have we got a square bracket? So this is just basically saying we've got a property array. So this is going to be an array. So the roles property here has an array, and this is going to be an array of stuff. So it's going to be an array of strings here, because you will find one of our persons in the database has more than one role. Okay, so all of this happened. So we're going to create loads of data, and create load of nodes, and create the relationships between them. And then at the very end, we have this query here. What's going on? Just quickly explain. So we've got with. So with basically says, hey, I created loads of variables and they're going to get forgotten, but I need to remember specific ones because I'm going to do something with them. So here it's saying with Tom H. So Tom H, if you look further up, is when we created a Tom Hanks node and we gave it an alias, a variable of Tom H as A. So as is now saying, well, actually I had an alias of Tom H, but I want to create a new alias of A. So with Tom as A. So remember the Tom Hanks node. Give it a new alias of A. I'm now going to match. I want to match A, which we know is a Tom Hanks node. So acted in. So give me the acted in relationship off of Tom Hanks node in M. So we know that it's always person, movie, person. So we can assume that this is our movie node. So acted in this node here, which we know it's our movie node. So we've not given a label, but we have a variable here of M. And then we want to know the directed in D. So we know here, because we know it's person, movie, person, this here is going to be a person node. We don't need to specify the label. We can if we want to, and that's a conversation for another day. Directed in D, then return A, M, D. So we're going to return A, which we know is a Tom Hanks node. We're going to return M, which we know is going to be the movie node, so the movies that Tom Hanks has acted in, and D, where we have we're going to get the director of those movies that Tom Hanks acted in. And then limit 10 just says, please just limit to the first 10 responses. Right, let's do this. Let's run this query. So I'm going to make it small again. We're going to press the play button, and that's going to create some data for us. So I'm going to scroll down now. I'm going to press this button here. So on the frame, you see this button with 2 arrows. This is going to expand it out. So if I expand out, you can see we've created some data. And we've also got an answer to our question, which was, what are the directors and the movies of the films that Tom Hanks has acted in? So we've got Tom Hanks, we've got all acted in. We go to the movies, so our movies are in blue. And we've got the directors here. And what you will spot, the sharp-eyed amongst you will spot that there's one where Tom Hanks acted in the movie and he directed it. So good so far. There we go. We now have some data. So I'm going to minimize that. So if you just press the arrows, the little pointed together, it'll minimize it. And I think it's time for me to be a little bit quiet and time for you to have go some queries. So what I would like you to do is I would now like you to go through each of these queries. So I'm going to give you about 5 minutes because we've got about another 28 minutes or so. So I'll hang around a bit longer. So for those of you who've got a bit more time, I'm going to answer all the questions that I don't get to during the session. I'm going to give you some exercises. So what I would like you to do now is to go through these. We'll give it about 5 minutes. And I would like you to look at each one, try and guess what the query is going to do, and then run the query. So you've got these queries. So have a think about what's going on. And whilst you're working through those, I will answer some of your questions. So you've got about 5 minutes. Let's do this. Okay. So I've got a question here. When using label new node with relation or property, addition child for Jane. Yes, you could create that. So as an example there, so Martina asked that. So what you could do is if you wanted to have your person nodes, so maybe you're using a graph to describe a family tree. So maybe you may want to, if I've answered your question correctly, you want to describe maybe specific items, and then yes, you could add additional labels on there. So we've got a question here. Is there any best practice for modeling relationship directions if both are possible and make sense for a human perspective? So that's a great question, Andres. And what I would say about that is, I would point to the modeling class, and maybe I'll run a modeling session on Twitch soon as well. So keep an eye out for that. But what I'd say with that is, you don't really want to do the recursive relationship. So I know that in UML class diagrams, for example, if you've got, for example, let's take Jane and the car, for example. So you have Jane owns car, and then you'd probably have reflective car owned by Jane. You don't do that here. So that's poor modeling practice. You wouldn't have any situation where you could infer what the relationship meant between entities. You don't repeat it. So in the example, you've got Jane owns car, you would have an outbound relationship from Jane to car. So we know that Jane owns car, and the fact that if we looked at car to Jane, that it's an inbound direction from the relationship of car to Jane, then we know we can infer that because Jane owns car, we can infer on that existing relationship that car is owned by Jane. So we wouldn't put two relationships in there. Now, if we wanted to recognize, so let's go back to our simple example of we're looking at insurance, maybe car insurance, and we wanted to understand not only who owns the car, but we want to know who drives the car. So let's say we've got Jane and we've got Dan. So Jane owns the car. Jane also drives the car. Dan drives the car. In that example, we could have more than one relationship between two nodes because we're now capturing different relationship conditions. So Jane drives that car. We need to know about that for insurance purposes. We also need to know who owns that car. But that owns relationship is different from that drives relationship. So we saw that with the Tom Hanks node where we had Tom acting in the film and he also directed that film. He's got different relationships with that node. So we have to capture that. So that in that situation, we do have more than relationships. So hopefully that answers that question. What have we got next? Predrag asks, what about updating the node property or related properties? Right, okay, you can do that. So we don't have an example of this here, but it's pretty simple. So let's see how we get on. So towards the end, we can have a go at doing that. But you can use a set clause. So if you don't have a property that exists, you can do something, actually for all of them, you could do something like match P person, name Tom Hanks, and then we could do set p.name Tom Hanks Jr. And that's how you could update the property and use the same convention for relationships as well. And you can use that to set new properties too. So it's pretty powerful. Let's see what else have we got. Is it possible to create data with Bloom as well? So at the moment, not yet. So you can duplicate relationships and nodes, but you can't create new data with Bloom yet. So that's out of the front. So one thing you can do, which is a bit hacky at the moment, is you can do search phrases, and within a search phrase, you could create data because you're writing Cypher, but I would hazard against recommending that, but that would be an option. And let's do one more question before we continue. What facilities does Neo4j have for concurrency control? So just a quick thing to mention. So Neo4j is an ACID database, which means it does. So it's not a eventually consistent basis. It is an ACID database. So you have mechanisms in there to deal with writes, so that you don't end up having issues with writing and it causing issues with your concurrency. And you do have strategies for parallel writes if you want to do high-speed writes where you hit different parts of the graph. So that's probably a bit advanced for what we're covering today, but it's an ACID database, which means you don't have the potential issues with an eventually consistent data source. And I would suggest you have a look on our website for further technical details about that. Right, okay. So let's continue. So hopefully you have found that interesting. We are now going to start adding some relationships. So let's have a bit of fun with that. So again, I'm going to give you another 5 minutes. So the same deal as before. Please look at each query, try to figure out what that query is going to do, and then run it and see if your expectation matches what came out of the result. And so same idea. So again, I'm going to give you about 3 to 5 minutes with this. So again, have a look at the queries, try and figure out what's going on. And again, I'm going to answer a few more questions. And then we're going to start doing some really fun stuff. So let's answer some more questions whilst you work through those. What have we got? Can you explain I assume that's the licensing situation with other tools. Okay, so with Neo4j Desktop, that is a useful developer tool. So you get Enterprise Edition in there, but that is for educational, evaluational, and development purposes. So you can't you can't use the database you create in Neo4j Desktop for production, that kind of thing. So I would recommend you go and have a look at the website and the license details around that. We do also have, if you're a startup, we do have a startup program as well. We do have an educator license as well if you're looking to teach Neo4j in various educational establishments. So if you want specific detail about that, ping me directly and let's talk about that. Let's have a quick look. Can we combine Python or PHP with Neo4j? We have an official Python driver, so that you can use, and we've got examples of people using that either in Jupyter or your various other favorite IDEs. PHP, there is a community PHP driver, which is unfortunately is not up to date maintained as it used to be, but you have got that for the 3.5.x version of the databases that you can use. You've also got you can use the HTTP driver, access it by HTTP. Let's see what we've got next. Getting some questions on Restream, so let's have a quick peek at those as well. Is Cypher the only language that we can query the Neo4j database? So Cypher is the main one that we use, but we do have a traversal API that you can use as well. So that's not Cypher-esque. That's more of the more sort of implicit talking to the database where you talk about how you're traversing and things like that. So what I would suggest you do is if you search for the Neo4j Java API, and that's a different way to talk to the database. So that's what you're going to use if you're a power user and you really want to specifically talk to the database, how you are going to, how you want it to run queries. If you want to be very specific about how it expands nodes, if you want to go depth first over breadth first, and very specific and how it goes down things. So yes, you do have that fine-grained level of control available to you. So that's through the traversal API. So if you just search for that on Google, you can find more information about that. Okay, right, let's continue. Hopefully this is all making sense and you're feeling comfortable with this. So what we've done, we have matched individual nodes, so specific nodes. We have been then querying nodes and relationships. So we're now starting to query person nodes to movie nodes. And yep, so having a good bit of fun. And we're starting to do some detail things here. So let's quickly talk about this last query here, because we have something that's a bit new. And you notice we have this type. And what this type function does, it's a Cypher function, and what it tells you is, as you may have spotted when you ran the query, is what is the relationship type. So if I just scroll down here, oopsie daisy, you can see here it is returning, what is that there? So you can see there's an acted in relationship between Tom Hanks and acted in, and you find all the information about that relationship. So there you go. So that's what's going on there. So that was a new one. Okay. Just a quick question. Is there a way to help with typing the correct node or relationship type? So, Rob, could you provide a bit more context around that question? I don't think I quite understand. And let's just quickly see. Got one more question. Okay, so Marvin asked a really, really good question, which was the statement match cloud atlas. Let me just copy the question and paste it in so everyone can see it. So the question here is, the statement match cloud atlas return doesn't make sense to me. Why wouldn't you have match movie title cloud atlas? Okay, so let's just quickly explain what's going on here. So they are both things. So what's happening here? So both cloud atlas and movie in this respect are both aliases. They are both variables. How can I tell that they're variables? Because I don't see a colon anywhere. So I don't see colon movie here. I don't see colon movie here. Do you see what I mean? So because we don't have that, immediately I go and go, this is an alias. So what's happening here is a variable name's being picked called Cloud Atlas, because the title of the node. So here it's looking at all the nodes, and it's looking for nodes that have a title property and a title property that matches Cloud Atlas. Here, just using a different variable name. The variable name here is movie, and it's again looking for a node with the same properties. So what's going on here? Because we've not specified a label, what the engine will do is we've not specified a label. So I'm now going to look at every single node, and I'm going to check whether any of these nodes in the entire database has a property of title with the value of Cloud Atlas. Now, if I take this, if I changed this query to include the node label of movie, what I've basically said to the database is I'm only interested in nodes in the database that have a label of movie. And what the engine will go, okay, I'm not even going to bother looking at the person node. I'm just going to ignore all of those. I'm only going to direct my search at nodes with the movie label. So it's a movie label, and I'm going to do that. So the reason why, so you don't need to specify a label when you're doing a query. That's completely fine. But what happens there is it will search the entire database of all of the nodes. So if we're working with a really small data set here, that's fine. It's going to come back pretty quickly. If you've got a database with millions and billions of nodes, that's going to be a slow query. Can you imagine if you've got 1 million nodes and you're not using the label? It has to search every single node, check its property, and see if that property matches. By putting the label in there, movie, I've helped out the engine. I've made that query that much faster because it knows it doesn't need to look at any other labels apart from movie. So hopefully that makes sense. So that's a great question. Okay, let's have a look at the next one. So this is where the fun starts to, this is where it gets exciting. I'm going to do some fun. So we are now going to have a look at some Kevin Bacon numbers. So I'm going to quickly explain what's going on here because we've got some new stuff coming up. So let me explain the new stuff, and then I'm going to give you a few minutes again to have a look at these. Okay, so let's have a look. So we are doing here. So we recognize this stuff. So we're matching a person node. We're going to give it a variable of bacon. And we're interested in the property where name is Kevin Bacon. Okay, that's good so far. We know that. We're looking for a node. We're looking for some nodes. We don't know what it is, and we're going to give it a variable name of Hollywood. That's fine. We can do that. So we've got some new stuff here going on in the middle. And this new stuff here is star1.4. So let me explain what's going on here. So up until now, we've just been looking at nodes that are one hop away. So literally, there's one relationship between two nodes. That's what we're looking at. What this syntax here is saying, well, actually, I want you to go out up to 4 hops. So from 1 hop, 1. So that's what we're used to. I want you to go up to 4 traversals out, 4 relationships out, and hit those nodes. So this context of star1.4 says go from 1 to 4 hops out and match all of the nodes that are up to 4 hops out from me. And then you're going to return them. And because we're going 4 hops out, now bearing in mind that we have the pattern of person, movie, person. Some you may spot we've got person, person. But the point being, if we do person, movie, person, that's now 2 hops. So we don't know the labels. That's why we've not specified label, because the label could be movie, the label could be person. But we want to catch them. We know they're nodes. So we've got Hollywood here. So that's fine. That's what's happening. It's going to match movie and person nodes up to 4 hops out from Kevin Bacon. Good so far. And we're going to return Hollywood. Now, the reason why we've got this distinct, and this is probably something to have a play in your own time, is what you'll see is we have many different paths, and we can have lots of recurring paths. So we can have the same result, but different paths going through it, because you're going to have same co-actors or different co-actors working for the same film and so forth. So that's why we've got distinctiveness. That's just saying, just bring me back the first one of that happens. So that's what's going on there. So that's the fun. So I'll let you have a play with that in a moment. And then the next one, this is great fun, shortest path. So shortest path, as the name suggests, is going to try and find the shortest path between 2 nodes. And what's going on here is we're going to match P equals shortest path. So this is a function. So this new thing here, this P equals, so P is our variable name. And this syntax here, when we do match P equals and then our pattern, basically says this is a path. A path consists of a single node. A path can consist of nodes and relationship nodes. So that's what it is. And you'll see it when we run it. So I'm not going to go into too much detail here. And we're going to run this on this pattern here. So again, we've got Kevin Bacon. We've got another node here, person node of Meg Ryan. And then we've got that star again. We've got that syntax. We've got our relationship. We've got the square bracket, and we've got a star. And what that says is go through, that's any number. So star means everything. So if we return star, we're returning everything. If we with star, we are carrying everything along with us. So star here means everything, unlimited. And what's going on here is we're saying match every single path between Meg Ryan and Kevin Bacon. And this is saying find the shortest path. Now, warning, just imagine big red triangles with an exclamation mark. Warning, warning, warning. Please do not ever run this star in a relationship unless you're running it within shortest path. And the reason why I say this, because you're thinking, well, hang on a minute, we've only got, and if I click on this little icon here, it's going to give us information about a database. And you go, but Lou, what are you talking about? I mean, we've only got 171 nodes. We've only got 123 relationship between those 171 nodes. What's the worst that can happen? So remember, we're looking at every single unique path between relationship and nodes. But a unique path can have many crossback traversals. So if you think about a film, so let's take Apollo 13, for example. So Apollo 13, you've got Tom Hanks and you've got Kevin Bacon. Now, Tom Hanks and Kevin Bacon have starred in many films together. And if you think about it, about the different paths that are joining them, they're going to crisscross across the films that they've acted in together. They're going to keep crisscrossing against the same co-actors they've worked with. So you're going to end up with potentially millions or billions of different paths between them. And this, and so this even with our tiny little data set, we could be looking at millions of different paths that connect these 2 nodes. So we have to be very careful about how we use this very powerful function that we have, because Cypher will let you. Cypher is Cypher will let you do whatever you like. Cypher's not going to go, whoa, hang on a minute. Do you really want to explore potentially millions of paths? Cypher will go, no, you go for it. So you have to be very careful. So this is okay to use within shortest path, for example. So be very careful about how you use this. So I've given you the warnings. I've spoken enough. We're running slowly out of time. So what I would like you to do here is have a go at running this, see what happens. Have a play, change Kevin Bacon to another name. So if you want to get some ideas of different actors' names or person names, what you can do is if you open up the database icon, press person here, and what that will do is it will bring you back 25 different person nodes. So there you go, you can find the names. So if you want to swap Kevin Bacon for Carrie Ann Moss or Joel Silver or Charles Ethan Theron to see what happens, go for it, have a bit of a play. Same idea with here, try changing through the different names. So again, I'm going to give you about 5 or so minutes to work with this. And let me answer some questions whilst you work on that. Okay, so a question. I got clarification from Rob, which was, is there a way to help with typing the correct node or relationship name, like person or acted in? So what you should find, Rob, is when you start typing, so maybe this is a good one to have a go with the person node. So if I start just typing my query, as soon as I open a bracket, it's going to suggest a label for me based on what's already in the database. So it'll do that. So let's say I'm looking for a person, and I can continue this query, and as soon as I open the square bracket, it's going to suggest available relationship types to me. Okay, so let me select this. And if I open that, it's going to suggest property names to me. So yes, you will get that helper available in there. How can I make the results? Nia asks, how can I make the results return indistinct? You've got an example there. So you've got return distinct Hollywood. If you wanted to return distinct property names, you can do the same. So you could do Hollywood.name, and that's going to return the names of actors, and it's going to return nulls for the movies because we don't have a name property on the movies. But yeah, that's how you do it. How can I use a graph database to store history records, e.g. the sales history for a company? Okay, so that's very much going to start moving into a modelling discussion, and I don't think that's quite the remit of this session today, but I think that's a great question. And what I suggest you do is have a look at our modelling course. I'm going to have links for the various trainings and things up at the end of this session. Also, our community forum is a great place to go as well. So if you're looking at different projects or if you've got specific questions about how to do things, I would recommend you go and post your question there. So that's community.neo4j.com. Let's answer a couple more before we continue. So I hope you're having good fun with the Kevin Bacon numbers. Have a go at changing Kevin Bacon to Tom Hanks. You know, who's got a better Bacon number in our data set? Is it Kevin Bacon or Tom Hanks? Have a play with that. Let me have a look at what else has come up. So, question off of free stream. Can I constrain my path search to go through specific nodes? Search for a way to go from A to X, but I know I want to pass through A, B, C, don't care between X. Reason because, okay, yes, you can. You can do that. That is possible. So, again, that's probably a little bit more on the advanced Cypher side. You do have that option. So you've got things, so you can use labels. So if you use a specific label, if you're doing your path hopping, you can. So let me pick this example here. I mean, this would be, actually, no, we could do this. I could do something like this. I could say : acted. So if I only cared about the acted relationship, so I don't want to know about directors, I could constrain how I expand that path using acted in. So I can specify type here. Also, we've got APOC, which is a helper tools that give you more, helps provide more advanced functionality in conjunction with Cypher. You can tailor patterns within your relationship. So there's a lot of power in there that you can do. Question from Fountainhook. Has Emil Ephraim recently really acted in Matrix? No, he hasn't, but it is unsurprisingly, he likes that film. Okay. Right, let's see what else have we got. Do you have a pre-built quality assurance routine to discover any statistical disclosure control issues within the data? I think you're going to need to provide a bit more context around that question, Nigel. Question from Predrag. Is it possible to create stored procedures and functions like SQL? Yes. Yes, you can. So we call them user-defined functions and procedures. So have a look. So there's two flavors to this. So you can create really tailored, really controlled ones as using something based on a Java JVM. So in Java, in Scala, and so forth, you create a jar, you drop it into the database, and you can then call it within Cypher. And another option you have as well is within APOC. So I mentioned APOC before, is if you know the Cypher you want to write and then parameterize it and create that into a functional procedure, you can do that as well. So you've got a couple of options around there. How to drop, delete certain relationships or entities. Yes, you can do that. We're going to do an example at the end. So hold that thought, Vijesh, and we will look at that in a bit. And how do I limit to get only one option of the shortest path? So at the moment, you should only get one path. So let's just quickly run this query, because I think, do we get multiple paths? So, okay, yes, you'll only return, in this example here, it will only return one path. You can return more than one path, but that's beyond the scope of the chat today. So one more question before we continue our journey here. So Anirba asks, can I change the default ball and stick display of Neo4j to something else? How hard is this? Right. So probably something to mention about Neo4j Browser. This is a development aid. So this is very much what you have here, but you do have options. You can use libraries. So you've got, for example, people go off and implement their own libraries to change how this looks. So you have the option too. We've got Bloom, which is beyond the scope of this session, but that's our Neo4j visualization tool. Again, you can search Neo4j Bloom. You'll get a bunch of stuff there. I regularly do stuff with Neo4j and Bloom. So if you're curious about that, have a look. I think I did, if you look on YouTube, I just Monday did a session on working with Neo4j Bloom. So if that's of interest, if you look to our developer guide, so neo4j.com/developer, and you look around there, we've got a whole section on visualization with Neo4j. Okay, so one more question before we continue from Marvin, which is, how come a query like this, match bacon person named Demi Moore, etc., which distinct Hollywood, I don't see even the person named Demi Moore? That's because this is a super tiny data set, and I don't think we've got a Demi Moore node in here. So the best thing I would do is, if you want to have a play with the different actors, is I would get a list. So let's take this query here. So I showed you how to get the person node. So you can click on this and it's going to generate some nodes. If you want to make it a bit easier and you want to get all the people nodes in here and we want to get their names, I could do .name. And I want to sort them alphabetically to make my life even easier. I'm just going to do order by n.name, and this will give me a list of all of the persons within the movie database. And if I quickly scroll through, I don't think we've got Demi yet. Oh, we have got Demi Moore node. So what might be happening in your example here is that Demi Moore might not have many links. So because it's a really tiny data set, not everybody's linked in there. So it could be happening that our shortest path just doesn't have a connection between, may not expand beyond those two nodes. So we can do that quickly together. So let's do that. So what I can do, I'm going to do some recycling, because recycling is good. So match p person name Demi Moore. I'm going to return that node. And what you can do within browser is I've returned the Demi Moore node, and if I double click on that node, it's going to bring it out, and I can double click again. Okay, so there are some connections there. So we'll probably have to look into that query, Marvin. I'm not sure what's going on there. Okay, so let's continue, because we have much to cover and we're already over time. So apologies for those of you who have to drop off. Please come back to video. The video will be available pretty soon at the end of this session, so you can catch the last bits. again, the sandbox is always available, so you can come back and spend a bit more time and at your own pace to explore them. As you saw, it's really easy to get this up and running. So let's do the recommendation engine for those of you who have got a bit more time. So I'm going to talk through these two queries because they're a little bit exciting. And they might be a bit scary because they've got a lot of text there, but don't worry. Remember, Cypher is a pattern matching language, so we just step through and see what's going on. So these are our two recommendation queries. So the first query is going to find co-actors, and this is where it gets exciting because we have a lot of co being used here. So what we're going to do, extend the Tom Hanks co-actors to find co-actors who haven't worked with Tom Hanks. So let's step through the query and see what's going on. So we're going to match a Tom Hanks node, and we're going to find all of the movies that he's acted in. And then we're going to find all of the actors that were in the same movie as him. And we're going to call them co-actors because they are his co-actors in that movie. Then what we're going to do is we're going to take, and we can do this, we can do a comma and continue our match. So that's what's going on there. We're then going to take all of those co-actors. So we're going to match all of those co-actors that were in the same movie as Tom Hanks, remember. We're then going to find out all of the movies that they have acted in and find their co-actors. Hence, they are Tom Hanks's co-actors. So that's where the co-actors are coming in. So we're going to find their co-actors. Now, bearing in mind, because that's a separate match from our previous one, so we've effectively got two matches going on here, what might happen is that, what makes sense, is that these co-actors could be Tom Hanks. So what we're doing here is we're saying, no, we don't want Tom Hanks to come back as one of the co-actors. So we're not Tom acting co-actors. And notice here, some of you go, hang on a minute, we've got like round brackets with nothing inside. That's okay. So because it's round brackets, we know that's a node. And what we know here is, just because of the data, we know that that's going to be a movie node, but we're not interested in bringing back any movies. We're not interested in any specific properties about the movies, so we can just leave it completely empty. That's fine. That's completely valid. So we're not Tom acted in. We know that's a movie node going out to co-actors, and Tom is not a co-actor. So that's what's basically happening. So we're trying to rule out any existing links that link Tom to that co-actor based on another movie that they may have done. And we're saying make sure that the Tom node is not the same as the co-actors node. So that's what's happening with those two. So that's the not equals. For those of you who are curious about the less than greater than symbol next to each other. And then we're going to return the co-actor's name as recommended. So these are recommended new co-actors that Tom Hanks could work with in a new film that he's not worked with before. And we're using that, remember that friends of friends pattern we were talking about earlier? So we're using that as the mechanism to find these new co-actors for Tom Hanks to work with. And what we're doing a little bit further, because we don't want to return just any order. No. We want to order them by strength. So we want to say which ones are probably the better ones. You know, we're going to list them in preference. And how we're listing the preference is this concept of strength. And this strength is the number of times that co-actor, this new co-actor, has worked with Tom Hanks's previous co-actors. And notice we've got that star. So remember I said star means everything. So in this context, count. So count is a function. It counts stuff for us, as the name suggests. It's going to count the number of different sort of common paths between Tom Hanks and that co-actor via the different existing co-actors that Tom Hanks has worked with. And then we're ordering by strength descending. So that's saying from biggest to smallest. So that's what that query is doing there. And let's have a quick peek at the next one. Then again, I'm going to give you a few minutes to have a go with this. So here we've got find someone to introduce Tom Hanks to Tom Cruise. So this is a different flip side. So what we're saying here is, so we're assuming here that Tom Hanks and Tom Cruise have never met before. They don't know each other. But what we're doing, we're looking at friends of friends. So we're looking at common friends between Tom Hanks and Tom Cruise, and we're going to figure out which one. Again, this strength idea, we're going to try and find out, so which of these, because they've got common friends, could introduce them two together. And it's the same idea, so let's look up. So we're looking for our Tom Hanks note, acted in movie, acted in co-actors. So we're finding all of the co-actors, the people that have worked with Tom Hanks before. Again, we're doing our second match queries, so same idea. We've got our Tom Cruise note, acted in movie, acted in, and we've got our anchor points. So all of the co-actors that we found here previously, we're using them to find those who have been in the same movie as Tom Cruise, and returning Tom Hanks, returning the movies that those characters been, the co-actors, the people that worked with Tom Hanks, and the movies that they worked with Tom Cruise. So that's what's going on there. So I'm going to give you a few minutes once again to look at that, and then we are going to start wrapping up. So let me look at some of the questions that you have asked whilst you have a go with those. And again, if you want to change the actors, please do. Have a bit of fun with it. So let's have a look at what has come up. So we have got a question here. Does Bloom allow visualization such as histogram, bar charts, etc.? So Bloom is specifically just on visualizing nodes and relationships, and it's all about effectively query-free exploration of your data. So I think the best way to get that is to have a look, and I have a look at my video from Monday. So look on youtube.com/Neo4j, and you should see it as a fairly recent video there. My colleague Adam has recently created a new graph app that allows you to create charts, so do check that out. Let me see if I can find a link on that, and let me have a look at what we've got up on Restream. We have, is there a way, so Fountain Hook asks, is there a way to use the syntax like 1 to 3 in the co-actors example? Reason, what if you want to go 3 or 4 levels deep? I find the Coco co-actors. That's a great question. I think you can do things like that, but I guess the questions that be, what problem are you trying to solve? So in this example here is we're doing a simple recommendations engine, and we're doing our recommendations based on who's already acted with whom. And I think what you're trying to ask is something different. So yes, you can do what you're trying to do, but my question would be that's probably not going to solve that's not going to solve the question you're looking to answer. Let's have a quick look. Does Neo4j have a database, procedures, and triggers? So you can create procedures and functions. So we talked about that a bit earlier. So you can either write your own. So we've got APIs for that, and then you create a jar, and then you can call them within Cypher. You can use APOC if you've got a Cypher-based one. With regards to triggers, yes, APOC also provides database triggers. So if you search in your favorite search engine, Neo4j APOC triggers, you will get documentation around that. Question from Ronnie. Do you have any specific sections to avoid supernodes and traversals? So I think that comes back to modeling and what questions you're looking to answer. So supernodes are only bad in certain situations and are only good in certain situations. Well, not good, but anyway, sometimes you don't have to worry about them, sometimes you do. That is very much a modeling question and beyond the scope of this session, but we are going to look at doing some modeling sessions, so keep an eye out for that. And I think we do a session on modeling. Yes, absolutely. Of course. I mean, I ad hoc do a lot of modeling sessions on my usual Twitch stream on Mondays at 4 p.m. UTC. So definitely historically I've done that, and I'm definitely keen to do an Ask Me Anything session on modeling too. So keep an eye out for that. Okay, so hopefully you've had a lot of fun with this. So let's look at the next section, so the next slide. And this is all about cleaning up. So let me quickly explain what's going on here, and then I can dovetail one of the questions that came up about deleting nodes and relationships. So this here, before you run them, let me talk through what's going on. So this is going to delete our entire graph. So remember, we do match n. So if you recall at the start, that means because we've got no label in there, we've just got our variable, that's going to match n. That's going to match every single node in the database. Now, because there may be relationships connecting them, we have to remove those relationships first before we do something with the node. So here, detach means it's going to detach all of the relationships, and then delete n, as the name suggests, is then going to delete everything. Now, we had a question earlier about how we did delete specific relationships or nodes. You used the delete keyword. So, for example, if I wanted to delete all of the relationships from my, let's pick Demi Moore because I've already got that in there. So what I could do is I could do something like this. And I want to delete all of the relationships between Demi Moore and any nodes that Demi Moore is connected to. I could do delete R. And that's going to now delete, as you can see here, deleted one relationship completed after 9 seconds. That's deleted that relationship between Demi Moore and movies. So if I come back to my Demi Moore node, so if I press that hourglass, it just refreshes the query, reruns the query. If I double click on Demi Moore, there are no more relationships now because I've just deleted them. If I want to delete, say, all of my person nodes as an example, so what I could do is I could do match and person, then I could do detach, delete, and that's going to delete all of my person nodes. So if I go back into my database, I've only got movie nodes now. You get the idea. So there you go. So that's a quick segue into deleting specific relationships and nodes. A quick thing to mention as well, this works really well if you've got a relatively small database. If you've got millions of nodes and millions of relationships, you do need to iterate that. So that's beyond the scope of this session, but that's how you can clear your graph. Okay, I know we have covered a huge amount of content today. It's been a whirlwind tour. Don't forget, you can come back to this at any time. You saw how easy it is to run this example. So as a quick reminder, if I want to run this session, so let me clear my database. If I want to come back to this movie graph and spend a bit more time on it, so let's say I close the browser, just go back in, launch a blank Sandbox, open with browser. I'll give it a few moments, and our good friend, the Write Code Guide, will be there waiting for us. I've got a question, how can I delete property keys? So you use the remove keyword. So unfortunately, I've gotten rid of my data, but you can use remove. So remember we did set, so for example, set n.name equals Joe Blogs. You would do remove n.name, and that would remove the name property from your specified node or relationship. So remember, our good friend is there. Look, the pane is there. So to get back into the Moviegraph example, we click on Write Code, and then we click on Create a Graph. And there we go. We are good to go once again. And like that, you can step through at your own time, test the queries, have another go, change names, have a go to create. We didn't do any create examples. So try creating your own name node. So I could do a create p::person, open curly braces, name : Lou, and I could have acted in the matrix. So have a go with that in your own time. So let's get back to the slides. So I appreciate we've run a bit over time. Hopefully you've had great fun with that. I will hang around at the end. So if you've got any questions, just fire them in. I'll keep an eye out. We can answer those. So we'll run a bit longer. So how do you keep going? So hopefully you're all super excited. You're like, this has been great. I want to play more with graphs. So let's have a look at some content that's available to you. So first of all, there's a really great database, graph database book here. So if you want to learn a bit more about modeling, why would you use graphs, and a bit more introduction around Cypher. So it's a little bit dated, but it's still a really good book. So it's the Graph Databases book, and that's completely free. You can download that as a PDF. If you'd rather have the physical copy, you can go to your favorite online book retailer and order a physical copy there. We've also got the Graph Academy, and we've got a huge amount of content there. So we've got things like learning Cypher, graph data modeling, administration with Neo4j. All of it is free content. And what you can do as well is you can become a certified Neo4j professional. So you can get a certificate as well. So you have to do the study. It's not easy. You have to do the study, you have to learn the material, but you can get a certified Neo4j developer certification, so you can go do the exam, get the certificate. So that is available for you as well. We also have the Neo4j community forum. So if you've got questions, like how do I do X, if you're not sure how to do something, if you're working on a really exciting project and you want to share it with the world, are you doing something open source and you want to get people involved? Are you building a new community driver? Anything like that, come join us in the community, tell us about it, ask your questions. We are there. So you've got some of the links up there, and we've got a bunch of other stuff as well. So like I said, me and my colleagues, we do regular live Twitch streams, so you can come talk to us, bring your questions. So I'm currently working on a wine data set at the moment. That's been great fun. So if you want to come and join me on that adventure, please do. So you can find out more on neo4j.com/developer/online-meetup. So you can find about a lot of the great stuff we're doing there. We talked about YouTube, so a lot of our videos are going up there as well. So youtube.com/neo4j. So check out that stuff. So, oh yes, last but not least, so this is a little bit dated. If you want to learn Neo4j with a lot of fun, we've got Summer of Notes. So this was a competition that Alex and I ran over August. So yes, I know we are fast approaching Christmas. It's still valid. It's still fun. We had 4 challenges. So we had beginner challenges and we had advanced challenges. And the beginner challenges, we start learning about modeling. So you've got hints there. You've also got the solutions there. You can work through it. Exploring a museum collection. So you go and you start having a play with Bloom and looking at pictures. Solving a murder mystery. Using route planning in Central Park. So you've got some really great stuff there. So if you want to have a bit of fun whilst you're working with Neo4j, I really heartily recommend you check out those challenges. So that's r.neo4j.com/sun-week1. Do check that out. Okay, and if you want my contact details, so you can find me on Twitter. So I'm at llazal. You've got my email address there, so lju@neo4j.com. You also got the community forums also. Community forums, super useful. So thank you very much for joining me. I'm going to hang around, so I'm going to hang around for the next few minutes. So if you've got any questions, let me pick up those questions now. So we'll wrap up in about 5 or so minutes. Thank you very much for joining me. Sorry we ran a little bit late, and have fun. Don't forget, have a go at the Sandbox, play with the different use cases, and join in with the fun. Okay, so let's have a quick look at what's popped up. So, is this session going to be available on demand? Yes, it is going to be available on YouTube super soon. So keep an eye out on YouTube. You will find it there. If you if you're on Twitter, have a look at Neo4j, have a look at me, Alex. We'll make sure we retweet the link for that video as well, so you can keep an eye out for that. Is there a truncate equivalent to quickly delete a complete table like in SQL? Yes, you can. You can basically delete. You saw the example there. I did it with the person note. So if you think of the group, so we only had 176 person notes, but you can imagine we could have a huge number of notes. So yes, I can delete by label. I can delete a bunch of labels. I can delete a whole relationship type. So yes, you can do that. You've got ways. Just a flip of changing it. Yes, exactly, Marvin. Absolutely. So there you go. So you've got Summer of Notes now in the Southern Hemisphere. So now it's timely. So maybe for us in the Northern Hemisphere, we're probably thinking, what summer? That was a long time ago. Yes, there you go. So there you go. For all of our friends in the Southern Hemisphere, now is a good time to check out Summer of Notes, and you can start thinking about your barbecue planning. Okay, so yes, we're going to do a session on modeling. So I think that's everything. Those were all of the questions. So I'll keep an eye on the chat. We're going to stop the video stream shortly. Thank you very much, everybody, for joining. I hope you've had fun. Please do, tell us about your graph journeys. I'd love to hear how you're getting along, what fun projects you're working on. So it doesn't have to be just for work. If there's a fun hobby or something you're working on, I'd love to hear about how you're using graphs for that. So thank you so much. Over to you, Alex.
Thank you very much, Lou. I can switch on my camera, I guess. Here we go. Thank you very much. I think we're done. Thank you for answering all those questions. Thank you everybody for joining. Thank you for asking all those questions. I think that makes it all more interactive and more fun. And like you said, I mean, everything will be available on demand. We will share the links later, maybe early next week or later this week. And we hope to see you all soon.
Yes, absolutely. Come join in. We've got a bunch of exciting sessions coming up. We've got online meetups happening at the moment. We've got certainly playing some really exciting stuff for you. So keep an eye out, keep watching, and come join us. We absolutely love it, as Alex said, when you come and interact with us. It's great, and it's really exciting to see how people from different countries came along. That's brilliant. I love that.
Yeah. Perfect. All right. Cool. Thank you very much all, and see you soon.
Take care. Bye.
Bye.